Okay, so today we are going to solve this problem, which is 778 swim rising water. So as per the problem, we have been given a n by n grid. So let's take this as an example, which is a 2 by 2 matrix, and we will start from 0 by 0, and we have to reach this, which is n minus 1 into n minus 1 grid box here, and we have to find the path which gives us the, how do I say, uh, the minimum path with the maximum elevation. So say for example, if we start from here from 0 1 and 3 and 0 2 and 3, we can see from the either direction. If we take this, the maximum elevation is 3, and even if we take 0 1 3, the maximum elevation that we'll get is 3. So the answer will be 3 in this case. And if we take this case as an example, we will have to start from the 0 by 0 grid and reach this grid box. Then if we take any of the path here, we can see if we take this path, the maximum value which we are getting is 24. If we take this path 0 1 and then this, we get 23. If we take this, then the value is coming as 22. If we take this, it is 21. But if we take this part which has been highlighted, then we are getting the maximum elevation as 16. So the end result is we have to find the minimum path with the maximum elevation. I hope this question is clear. So normally we make use of the shortest path algorithm, which is also called the Dijkstra algorithm. So we'll try to implement that, but there will be a certain variation in that problem. So we will be storing, let me open my code. Okay, so we'll be creating a heap queue, and we will be storing the row column as well as the grid value. We'll be storing these values inside the heap queue, and then once we reach this end, which is n minus 1 and minus 1 grid box, then we'll be returning the maximum value which has been stored in the grid in the heap queue till that time. So let's start coding it. So first we'll have to, like in any BFS algorithm, first we will have to keep track of all the nodes that we'll be visiting. So we'll create a visit set. Next we'll create an let's call it queue for simplicity, and we'll be storing two values here. One will be the value of grid, the starting grid point, which is grid 0 0, and then we'll be storing 0 0 as this is the starting point. Let me add this grid here. Okay, this is done. Why is it giving me error? Oh, I didn't copy data. Okay, so this is a queue, and we have a set also where we'll be keeping all the boxes which we'll be visiting. Next, we will keep on looping through this queue. We'll keep on looping through this queue till it becomes empty or we reach our destination box. So what we do is we pop the queue. We'll do heap queue dot pop. Heap queue dot pop queue, and in return it will give us the height, the row and the column. Okay, in this grid we can either go in four directions: up, bottom, left and right. So we'll create a direction array which will help us in moving in those directions. So if we want to move to the left, it will be -1 0, and similarly it will be 0 1. Sorry, let me write this again. There will be four directions. This 1 0, 0 1, -1 0, and 0 -1. So this will take care of our movement from one grid box in all the other four directions. Now if we have reached the end boxes, the end box in the grid, then we will be returning out the value. Since I'm not in a method, I'll just write the print statement. We'll print out the h, and but if we are not at this particular grid box, then probably we'll have to go in all the other directions. So we can do is dr, like directional change in row and directional change in column in direction. Okay, then we'll add, we'll get new row and new column. So we'll add this value r plus dr and column plus tc, which will give us new values for row and column. Then we'll have to add the boundary condition. New row, new column should not be less than 0, or it should not exceed the boundary condition of the grid, like greater than equal to len of grid, or new underscore column, sorry, row should not be equal to len of grid. Since it is an n by n grid, so that's why I'm not taking different dimensions for the row and the column. Or if new r new c is already invisited, then also we won't take any action. Then we will simply continue. Okay, so this is the boundary check. Okay, I haven't added that, we have already visited 0 0. Okay, so once we have done this, we have added a boundary condition. Next step will be to update our q. So as we know that q will take two values. It will be the maximum height of the current cell, as well as the maximum value which is present in the queue at the present time, or the maximum value of the next cell it is moving to. So max of h, the value which we are popping up, or the new row and column. So if you are getting this point, we have to find the maximum value in the minimum path. And also, since we'll be pushing it into a heap queue, let me add that heap queue dot heap push. The heap queue dot heap push takes two arguments. One is the queue where we'll be pushing the result, and the next is the value which we'll be pushing in, which will be our new row and the new column. And once we have done that, okay, set close. No, it doesn't. Now it's fine. Then we will be adding this new row and column into our visited set. Because we have visited, that's why we will be adding this here to keep track of everything. Okay, so we have this grid, we have the visited set to keep track of all the row and column values that we are going through. Let me correct this. This is done. Then we are creating a queue. This is the direction. This array represents all the directions we can move into in a grid: up, down, left, right. And we will keep on doing it till the queue has some values. We are popping the value in the queue, which is height, row and column. If we have reached our destination, we are printing out the value. If we haven't, then we will be going in all the four directions and checking if we have exceeded any boundary conditions or not. And in heap queue dot heap push, we are trying to find the maximum value which we have encountered in our path till now. So let's try to run it. So we won't get one answer right now, since I've added a print statement which will be replaced by the return and lead code. So let's see. Okay, heap queue dot heap pop q. Is there any issue that I have done here? try this. Okay, no, it has to be two arrays. Expected 3 got 1. Let me see. We are getting 3 values. Then where is this error occurring? Oh, okay. Understood. I forgot to close this bracket there. Now it should work. 16, 4, 5, 16 is the one that we are getting here. Okay, let's try to add this here and see if it is working as expected. No, no, it's not. Let's revisit the code. It's working fine. If row is equal to line of grid -1, and this has to be and, not or. Let me see. Yeah, no, it's working fine. So this condition was incorrect. I was checking either if we have reached this value or if we have reached this last column. Ideally it should be and between the two, so we can confirm that we have reached the last grid box here. So now it is working as expected. Let me submit the code. It is passing. So yeah, so this was, let's analyze the complexity. It is n square log n O n square. Yeah, that's pretty much from my side. Alright, thank you.